recording. Okay, so good morning, welcome, and thank you so much for joining us today on this webinar where we aim to present the progress and the outcomes from the research and innovation activity iFly. My name is Ana Maria Morales. I am part of the research and innovation group of Atos in Spain, and I will be the moderator of this session. Before starting, just a quick reminder to mute yourself in order to avoid interrupting the speakers. We will have a Q&A after the session, but if you want to ask something specific during a specific presentation, please use the chat of Circuit, and then we can answer you at the end on the Q&A. Last but not least, we will make all this material available for you, the recording, the presentations, as well as other material that you might find interesting for sharing with other people. Just before starting, a recap on the agenda. We will start with a slot devoted to the iFly marketplace and a demo. Then we will move on to see which are the different services that have been developed and which are available also for acquiring and deploying through the marketplace. After this, our partner from Ferrovial, one of the biggest critical infrastructure operators in Spain, will share the experience of the company within the project for the validation of the marketplace and the services. And finally, we will end the session with a presentation focused on the business model and how we think iFly is going to be commercialized. So our first speakers, Enric Pages and Ana Soto from the New Media Edge and Software Technologies Unit at Atos Research and Innovation. Enric, Ana, the floor is yours. I will stop sharing the screen.
Okay, thank you. Now let me share my screen. Can you see it now?
Yeah, perfect.
Yes.
Perfect. So good morning, everyone. My name is Enric Pages. I'm the project coordinator. And first of all, I will briefly give you an overview of the project. This slide shows at a glance some basic information about the iFly project. Its formal name is Enabling Effective Unattended Aerial Vehicles as a Service Market. It is an IT digital project developed under the digital tech area, and the duration of the project is 1 year, which starts at the beginning of 2020. This project is partly funded by the European Commission through the EIT Digital. For the ones who didn't hear about EIT before, they are a leading European digital innovation organization, which drives Europe's digital transformation through investment in strategic areas in order to accelerate the research-based digital technologies. The consortium of the project is composed by 5 partners: Atos, who coordinates the project and acts as a business champion of the developed solution; FBK, the Fundazione Bruno Kessler, who takes the role of technology provider. They are in charge of providing cloud computing and storage technologies for the marketplace backend. Then we have 3 partners: Ferrovial Aeropuertos España, and CA3, who is a foundation associated with Ferrovial. And these 3 projects supports the project for the piloting phase. So moving forward, what is iFly, or which challenges aims the project to solve? Nowadays, drones provide a cost-effective solution for infrastructure inspection. They can help in several inspection and surveillance scenarios across different sectors: utilities, agriculture, logistics, public sector, but also many others. And they can be used in order to apply computing and AI technologies dealing with the complexity of the data acquisition and data analysis needed during these inspections. So focusing on enhancing the inspection process on critical infrastructures, iFly delivers a comprehensive platform to easily deploy artificial intelligence and computer vision services, as well as other IT services mainly related with the big data, across drones, cloud infrastructures, or edge devices, to boost the inspection operations on these critical infrastructures, such as gas pipelines, power lines, railways, roads, among other scenarios where it is applicable as well. So the eFly marketplace contains ready-to-use models in a variety of computing domains, and these models can be executed on different computing environments to support the data processing and analysis pipelines. So I would like to give you an overview about where we come from, because eFly is not something that we start from scratch. eFly leverages an existing AT Digital project called eFly, sorry. And the project is conveying distributed AI-enabled image processing techniques for the detection of incidents in a gas pipeline infrastructure. And what we did in the current project is extend the iFly results, building a marketplace on top of the framework developed in iFly for allowing the automation of the life cycle of these computer vision services, that we provide within our catalog. These are associated to drones and provide the environment needed by these services to run in automatic fashion, let's say. So how the platform works, for us there are two types of target customers that we identify. On one hand, we have owners and operators of critical infrastructures that can contract and deploy the IT services for enhancing their inspections. While in the other hand, we have drone operators that can be selected for a given inspection or even enhance their offering, contracting the computer vision service offered by the catalog of the marketplace. So the marketplace front end aims to capture the data and infrastructure pipelines needed for the inspection process, as I say, and these planning steps help us to build the environment for the computer vision services to run, and also to choose the appropriate ones from the catalog that we offer. The catalog of services includes storage and tagging of video and photos, on-demand video for alerts and incidents, 3D cloud image creation, anomaly detection of algorithms, categorization of elements, geolocalization-based representation of alerts and incidents, data fusion for alerts with a natural language interface, and terrain over flight, including history. You are going to see later on in one of the presentations all of the services in more detail. And that's all from my side regarding the introduction. And now I'm going to give the floor to my colleague Anna, who will go through the marketplace and will show a little bit also the backend. Let me stop sharing.
Okay, hello all. My name is Ana Soto, and
can you share your screen, Anna? Okay.
Yes, I just.
Now we can see it. Perfect.
Okay, perfect. We're going to start to a marketplace demo, explanation of the different parts of the platform, and finally the deployment. Okay. Okay. This is the main page. On the main page, we have a description of the marketplace platform. We indicate that it's a platform when you can easily deploy service for UAVs for UAVs drones oriented to artificial intelligence, computer vision, and other similar IT services. Okay, this is working for UAV providers and for critical infrastructure inspector or companies that want to deploy any service. This is our service, okay. We have a login in this page. Then we can create a new account. Sorry, this is the, we can put the email address, username, full name, a company, UAV provider, or a company or final user. We can upload the logo of the company, etc. Then after login, we have a questionnaire. Oh, sorry. 1 second, please. Okay. We have a questionnaire here. Okay, test company. We can edit. Well, in this step, we ask if we have a drone fleet or no. Then is yes, what type of drone do you have? We can choose. Interested in here we can put the inspection, which section, a phone, address of the company, and a brief description. Then in the attitude part is where we put the most emphasis on knowing what the end user needs. Here we can indicate how the structure of the service offers is formed. This is planning, data capture, data processing, and data analysis, and data presentation. We establish how the structure must be followed when making an inspection and is composed. We also offer a form that we have seen in this page, and in the attitude drop-down, we also find the section of software, hardware, and critical inspections SAE. Okay. Okay. In this part, we have a brief description that what is a visual inspection, why it's important, which benefits can we get of do this from drones, and which type of industry what and which type of industry we can choose. Okay. Okay. In the hardware section, we explain what type of drones, edge device, and public cloud environments are the most suitable for developing this activity, as well as a device such as Raspberries, NVIDIA Jetson Nano. We have focused on this project in this device, and the cloud infrastructure that Amazon Web Service, Microsoft Azure, Google Cloud, and Fog Atlas, environment of our partner FDK. Finally, at the software section, it's a brief summary that how is the capsule, the service is formed. Okay. Then the service that we offer in the IT service catalog section, we can access each of them and see a brief description. That we have restaurant tagging, on-demand video alias, 3D cloud image creation, etc. And finally, we have the marketplace. Okay, here we can choose any service, and then we are going to deploy. Okay, so what do I get if I make a purchase on iFly Marketplace? I get a computational environment with the service required for this region. This is I'm a final user. Okay, I'm going to marketplace one. And what kind of inspection do I want to do? I have my questionnaire, and the final I have the UE service required, my cloud environment, UAV provider if I need drones, and the devices if I need. Okay, this is a summary. Well, this is a demo of a deploy from NVIDIA Jetson Nano. This is the deploy of a capsule similar to a final UAV service. Okay. One of the examples could be this. Okay, we have the deploy, we have all the steps, and finally we get this. This is only an example. Okay. we have another. Okay. Okay. The simulation that we have seen is an example of the execution of capsule or containers that NVIDIA offered us for its work for NVIDIA Jetson Nano. The capsule of the computer vision service will work in a similar way. Okay, this is a deploy from a UAV services, anomaly detection and categorization of elements from Amazon Web Service. Here we see the service. And the deploy. We got an error because we haven't got any video for input. This is the reason for the error. And finally, we have also added the ability to deploy to multiple devices using Ansible, a configuration manager. Okay. Ansible is an orchestration tool that automates software deployment. This means that having a master, a node master, or laptop, for example, we can install, deploy, or interact with several devices at the same time instead of going by one. To better understand how the configuration manager works, we have created a very simple scenario composed of a Raspberry Pi and NVIDIA Jetson Nano connected to a computer. Okay, this is our control node or multiple node. First, we check the connectivity and then deploy the capsule. Okay. This is the same way from an Amazon Web Service instance. It's the same way. It works in similar way. And finally, we have a deploy from of a UAV service from this orchestrator. First, checking the connectivity. And then deploy the capsule. This is all for my side. As have we seen, the iFly Marketplace is an innovative platform, and not only because of the technology it's used for artificial intelligence or computer vision, but also because it allows drone providers to obtain clients. We have the example of AeroTools, a company that operates with drones, being registered on the platform allows them to gain customers and buy UAV services to improve this inspection and operations. This is all for my side. I stop sharing. Thank you all.
Thank you, Ana. Okay, so now the turn is for Jose Ramon Martinez that will tell us a little bit more about the services. Jose, please go ahead.
Yeah, okay. Thank you. So now we are going to talk about the software services, which at the end is the, let's say, the meat of the project. The marketplace is the front end, the how to deploy, let's say, and the things we are going to deploy, the things that provides value to the proposition, let's say, are the software services we have built. Okay, so these services at the end are application services that can be deployed and used under user demand. And the idea is that these services can be deployed potentially in, let's say, 4 different, in fact, devices, depending on the service, of course. The first one is in a local edge, let's say something like an NVIDIA Nano or similar that can be run on board of a UAV or in an IoT hub, for example. On remote, in a centralized edge computer, let's say like a Bulsequana, for example, and for example in the cloud. The fourth one, of course, could be a normal computer. Some of these can be deploying a normal computer acting as a server also. Well, the rationale of all these services we have created is to create independent on-demand applications, services, let's say, that can be used for improving, enhancing the inspection of critical infrastructures that now are made, let's say, manually, and always, or most of the time, let's say, supported by the use of drones. All these services are for visual inspection. I mean, inspections based on cameras. Usually these cameras can be installed on board of drones, but also could be, for example, placed in fixed places or on vehicles. At the end, all the services are independent, but it makes sense for them to work together. And as a whole, the idea is to provide something that can be used for any provider needed automatic detection of anomalies, enhancing the inspection of critical infrastructures. Sorry. So that's the idea graphically. You have your inspection in the field, for example, of a power line using a drone. We can provide services to improve this report of an incident that you are creating, the video, the position, the tagging, the 3D reconstruction, etc. So you can process your alert in your central place. So what are these services? Well, the first one is the service for storage and tagging of videos and photos. And here the idea is that you can create videos and photos using, for example, a drone or a camera of the incident. And then with this service, add any number of annotations or tags that can be useful for you for the report for the incident itself. And the idea here is that this kind of service could be deployed and installed in a cloud, for example, because it makes sense to deploy the report with the details with annotations in a cloud. Second one is on-demand video to the exact time. The idea here is, okay, you have your video of the incident, but the video is very long, 10 minutes, whatever, and then you want to have your incident localized in a certain time, and you want to retrieve the instant of the problem for not losing time. So here with this service, you can request, give me the video of the incident in this exact period or in this exact time. Again, this makes sense to be installed in a server or cloud. GIS-based alerts and incidents. Here the idea is that we can provide a service base, a GIS base in a service, providing the location of the incident itself. You can have many inspections in many different places. And for example, if you have a power line, this could be very, very long. So it's very important that everything should be geolocated, sorry. And it's very important to provide a way of putting that into a map so you can navigate to this map and request the incidents of certain tower, etc. For example, in their service we provide the backend and not the front end. 3D cloud image creation. The idea here is that using the footage of the camera of the drone, for example, you can create a 3D image of the overflight. So you can manipulate this 3D image, or you can use it, for example, to detect anything. Later, we will see a demo of this, and we will see how we can use that, for example, to detect if any vegetation is inside a power line, for example. It goes without saying that this process of 3D creation is not real time. I mean, it takes hours and have to be done in a computer with, let's say, medium power. Related with the former is a terrain 3D reconstruction, and here the idea is that if you could provide us some coordinates, we can look for historical images of the same place, and then create a 3D reconstruction of the history of the place, so that now you can compare the state in the past and in the future. And this could be very relevant, for example, if you are planning to do anything new, if you are planning to know what is the status of the terrain, the evolution of the terrain, for example, for a power line, for a gas pipeline, for example. Totally different, the data fusion of alerts. The idea here is that it's a client that can be used in combination with the other services, and with this client you can create the alerts using natural language, create the alerts that can be provided by the services. Finally, the last two ones are things that can be run on board of the drones in real time, typically in an edge device. The first one is the anomaly detection algorithm. The idea is using the footage of the drone in real time on board of the drone, you can detect anomalies, whatever anomalies. For example, in the footage we have anomaly related with a gas pipeline. And very similar categorization of elements, and here the idea is to categorize the elements that you are seeing in the footage in real time, and then typically the idea is to send the image of the incident or the footage, a small footage of it, a small clip of video, let's say, or just a text report, typically in JSON, for example, things like that. Again, this makes sense to be installed in an edge device. All these services, the idea is to deploy them as Docker containers, and then to combine them using Docker Compose. Why? Because it makes sense for some of them to go together. They are independent, but can work together. And because some of them need a database, and we can also Dockerize the database and put that into a Docker Compose. That way, they are very easy to deploy using the marketplace and very easy to change. Finally, a small remark about the edge devices in case you don't know them. The idea is that now we are using these kind of devices which are very, very inexpensive and very light, but at the same time they are very powerful. Let's say that for less than 500 euros, you can have a very powerful device on board of your drone that can run very powerful algorithms of detection, categorization, etc. in real time. And we use this approach for the algorithms of detection categorization that we are running in this project. And now a demo. I have two videos of the demo. The first one is, well, these videos are demos for this project. The first one is about the detection of the status of the pins that goes in the screws of the electric towers. Ferrovial was interested in knowing what is the status of these pins, if they are okay, if they are rusted, if they are missing, things like that. At the end, this is run in real time on board of the drone using NVIDIA Nano, which, if you don't know it, by the way, I have it here, goes into a, well, this is inside a box, but this is the size of it, of this NVIDIA Nano. Then I have another video that I can show you, which is the 3D reconstruction of the terrain. Okay, let me open it. Sorry for that. Okay. And what we can see here is the 3D reconstruction of the space between the two electrical towers. It's the 3D cloud. Of course, this takes hours to be computing in a computer. The cylinder you are seeing is the catenary of the cable. We have drawn 2 cylinders around the catenary because these are the places, the areas where the client wants to know if something is inside. In blue, for example, you can see vegetation. The idea is, okay, is there any vegetation that intersects with this side planes that we have, or the cylinder that goes around the catenary? Because if there is something intruding this area, then there is an incident, and we want to detect this incident automatically. This has also been made for this project using Ferrovial's data. And that's all. So questions later, I guess. Thank you.
Thanks, Jose. Okay, so now we move on to Javier Murillo from Ferrovial. Javier, are you sharing your screen, or do you want me to share?
Yes, I can share it.
Perfect. So go ahead. Thank you.
Okay. Let me know when you can see the...
Now. Yes, we can see it. Javier, I think you're on mute. Javier, we cannot hear you. Javier.
Okay, Javier left, so maybe we can exchange the order of the presentation. Yeah. Maybe we can go first through the customer development and the business cases, and then afterwards go with Javier's presentation.
Yeah, definitely. So Jorge, can you please take the floor now?
Yes, I will quickly share my screen. Okay, you should be watching my presentation now.
Yes,
right?
We can see it now.
Okay, I'm going to briefly present the business aspects of the platform. As my colleagues have already introduced, simply put, iFly is a UAV or drone as a service marketplace where customers can request, for example, a full inspection service or part of the service without having to maintain drones or having to know how to use them, and this marketplace enables the sale of these IT services, for inspection of the infrastructures. The services are related with artificial intelligence and computer vision, can be automatically deployed on all the environments that have been presented. We can define who are the customers. Enrique has already introduced this. We have 2 main segments of customers. First, we have the end users, which are the infrastructure operators or owners of many different types of infrastructures, electric, water, transport, other. They need assessment and monitoring of their infrastructure. They might have drones, so they will request some of our services that can be purchased from the catalog of the marketplace. So here we have the potential buyers from the marketplace, which are also the end users. And then we have the drone service providers, who in turn are hired by these end users. But they can also buy services from the marketplace, but they can also become sellers. So they have a dual role. They can sell their services through the marketplace. Typically, as buyers, these drone service providers, they will demand different services than the infrastructure operators. Services more basic in terms that they are used earlier in the value chains of the inspection. And this is a high-level diagram of the overall value chain of the inspection service with drones. You can see at the top the different steps, the high-level steps, and below the different layers involving the personnel, hardware, and software. So in this landscape, in the first step of the marketplace is going to offer these segments that you can see in blue, which are the algorithms and components to be deployed and executed that have been presented by Jose Ramon. And also we provide the underlying infrastructure required for the acquisition and deployment of this. So in the list of the initial services that will be on sale that have been presented by Jose Ramon, we estimate that these services can be ready for the market approximately by April next year. And in this list, we can distinguish two groups. This first group, anomaly detection and categorization, is more oriented to specific campaigns, more oriented towards drone service providers. They are services that can be deployed in edge devices. And this other group is more oriented toward permanent services, and more oriented toward infrastructure of owners who operate their drones. And additionally, we can also, as I said, advertise other drone service providers, the services of other providers, and we can also develop on-demand algorithms with adaptations for different functionalities to cover the rest of the inspection services. So the revenues stream for Atos, well, here Atos plays two roles. We are the marketplace operator, but we are also the vendor of the initial vendor of initial services. So in this role of vendor, we will charge probably a fixed fee per deployment of each service. The price to be charged is yet to be determined. This fee will include the support, for example, during a year. If you have purchased the service, if something fails, it will be supported. There will be also the option of deployment on cloud and pay-per-use on the cloud provider of your choice, for example, Amazon or other. So here we will pass you the bill on the computing and the storage on the cost of computing and storage plus a fee for Atos. And probably we will provide beta access for cloud service for some time for free, so you can be sure that this service meets your needs. And as market operator, we can promote also other vendors. So the fee for this promotion at the beginning will probably be low until we have enough mass of visitors. And looking to the future, in the second phase of the marketplace, we plan to add add more services to the catalog to complete the value chain of the inspection service. For that, we will include other vendors than Atos. To do this, to have other vendors, we will have to implement technology to manage the payments, to collect and share the payments on behalf of the vendors. When we do this, this will allow us to charge a commission on the sales by the vendors. And also in the future, we can extend to other domains, not only inspection of infrastructures, but other domains, I don't know, inspection with drones of security of crowds of people in cities or other, like I said, or other domains. This is a summary of the overall business model that I have explained. I just have prepared this in case it is of help. If there are some questions about any aspect of the business, and that is the end of the presentation.
Thank you, Jorge. Okay, so we have Javier in line again, but just to be sure that he's not losing connection, I will be sharing his slides.
Thank you, Anna. And good morning, everybody. I'm sorry for that problem before. So
okay,
when
now yes,
we are ready, perfect. So as Anna said, I'm sorry for that mistake with the connection, that problem. And then thank you, Atos and FPK, for having me in this project. I think it's such a good collaboration, such a good project. So here in my presentation, I'm going to introduce you a brief overview over the Ferrovial company, okay, its business lines, and how we can use drones in Ferrovial. And then in point 4, okay, we are going to explain the fly use case. So starting for the overview, okay, Ferrovial is one of the world's leading infrastructure operators. Okay, Ferrovial has been including MSCI's Sustainability and Responsible Social Investment indexes since 2014. And for example, the FTSE for Good also renewed Ferrovial's listing in its last 6 monthly assessments, with Ferrovial now having been included in the index for 17 years running. Okay. If you continue to the next slide, Anna, you can see which that Ferrovial has a global presence, okay, in the world, specifically in 17 countries, with main offices based in Spain. Okay. In the next slide, you can see the business lines we got in the company. Okay. To roads, airports, and power infrastructure, who's the business line who join us in this project. Construction with Ferrovial Construction and Ferrovial Services, which now we're selling, and then Ferrovial Mobility, which is the new one, okay, getting Wandel and also City car sharing company. Okay, so the company's activities carry out through this 5 business line, covering the whole infrastructure life cycle, from design until operation and maintenance, right? In the next slide, okay, we can see how we use drones in Ferrovial, because Ferrovial provides efficient provision of urban and environmental services, offering infrastructures. And we have also developed drones, the drone technology for different applications, such as all the infrastructure inspection, construction site, active management of birds at airports, etc. Okay. So now going to the fly use case. Okay. Today we are going focusing Ferrovial power infrastructure. Okay, this is, as I said, this is the business unit taking part on fly, offering its experience in infrastructure inspection as well as use case to develop the requirements for this pilot. Okay, we apply integrated approach to project management through the synergies generated within our businesses to design, build, operate, maintenance the assets. Okay, the experience of the team allows us to identify the most efficient and profitable opportunities. Not only are we committed to offering operational excellence, the highest level of security and innovative solutions, but we work in collaboration with Atos in this case and the interest groups to understand their needs, challenges, and incorporate them into our business plans to ensure the best possible services. Okay. In next slide, you can see which is the infrastructure for this pilot. Okay, it's Trans Chile. Okay, it's between Charrúa and Cotín. It's 200 kilometers of the power line. Right. So we are now I'm going to explain what is our need in this project and what are the objectives we are looking for. Okay. In the next slide, please, Anna. This is our need. Okay, the 4 services we were tested in this pilot during 3D reconstruction with José Ramón showed a video showing the images of the 3D reconstruction, the 3D model. Also, GIS-based alerts when the vegetation gets with the maps, that we define. Also, automatic categorization with the cutter pins and identification of elements and anomalies. Okay, because save time and cost to remain competitive in future tenders, allows anticipation and early warnings, facilitate the visualization of areas that has difficult access. No, analyzing the process with some of the inspections can be done by drones. So with these 4 UAV services, we are getting many benefits in this project. So definitely adding value with an innovative solution, improving the traditional methodology, and in consequence affecting other areas. All right. And in the next slide, also this is why that we think that artificial intelligence add value for the inspection, but now only 5% of data, as you see there in the square, created by UAVs processes. Okay, because there's some problems with connectivity, bandwidth, and computing limitation. So through this pilot, we have been able to test and see how we can improve that data connection, that bandwidth, and how we can improve in this field in order to get more benefits on it. Okay. So in the next slide, you can see which is the difference. Okay, that we can get with eFly marketplace and eFly services. Okay, with traditional inspections, you see this is pretty normal now, that all the things that we already have been done, but now with the iFly marketplace, we can get multiple data sets in a single flight. We can get automatic deployment of these services thanks to the marketplace, and also real-time inspection. That it's pretty good because we can get early warnings. Okay, we don't have to wait for process all the video, all the data. We can get on the field that if there's any trouble, any problem that needs an early solution, we can move the team to solve that. Okay, and then in the next slide, you can see the benefits from using drone edge computing. Okay, that's the main thing, the main goal in this project, to get that drone edge using the drone edge computing, because we can save cost and time, rapid data collection, access to difficult areas, because also get multiple data sets, real-time data processing, simplifies maintenance tasks, and also assessment with the evolution of the incidents, and as I said before, early warning. So as a summary, okay, I think the contribution of this project, the contribution of artificial intelligence in the edge of the drone makes a lot of benefits in this technology, in this sector, in this market. And also thanks to iFly Marketplace, we can get with only one tool. Okay, so thank you for your time. Thank you, Anna.
We cannot hear you, Anna.
Oh, I'm sorry, I was on mute on the headset.
Okay,
Okay, so thank you so much, Javier, and everyone for joining us today.
Thank you.
Now we have space for questions. So I don't know if anybody has a question, but in the meantime, I would like to ask Jose Ramon, which other applications besides inspection of critical infrastructures we can also acquire and deploy through this kind of marketplace?
Well, at the end, anything that needs, let's say, artificial intelligence as a service, let's say. At the end, the idea is that we can extend this same idea to deploy anything inside a Docker, let's say any modular thing inside a Docker that can be run, for example, on board of a drone or in a central hub controlling, for example, cameras. For example, in some other applications, we are thinking about controlling the cameras of a mall. And the idea is that you have a central hub, and in this central hub, you control, let's say, 10 cameras at the same time with the same device. And in these cameras, you can have, for example, detection of and tracking of people, following the same person and re-identifying the same person in different cameras, etc., using these kind of devices. So there are many applications that can use the same concept of marketplace and in general of artificial intelligence as a service, let's say.
Thank you, Jose. That was my question. Does anybody from the external participants has any question? Doesn't seem so. So thank you so much for joining today. We will send you an email with the recording of this session, the presentations, and in case that you want to know more about iFly or the services, the marketplace, feel free to contact us. We will be more than happy to have a dedicated call to see in which part are you interested. So thank you, and thank you to all of the speakers. Have a nice weekend.
Thank you, Anna. Have a good
Bye.
day.
Thank you.
Bye.
Thank you. Bye.
Bye-bye.